Next we are going to see a numerical based on operations of signals. Okay. For this numerical, there are certain things that you have to see. Okay. There are certain things that you have to know. All right. What you have to know is operations of signals. And you also have to know the signal multiplication. These are the two concepts that you have to know. If you don't know these two concepts, you won't be able to solve the numerical or understand anything that I am going to be talking in this lecture. Okay, so I suggest you, if you don't know these two concepts, I have already uploaded the videos of these two concepts. So you all first understand those concepts and then come and watch the video of this where I am solving a numerical on this concept. Okay, let's start now. The question is, a discrete time signal x of n is given by one two 1 1 2. Okay, my origin is at 2. Okay, the arrow means that the origin is at 2. Sketch the following signals. X of n minus 2, x of n plus 1, x of 3 minus n, x of n into u of n minus 1, x of n minus 1 into delta of n minus 1. Okay. Now usually for Mumbai University, these such questions are asked for 8 to 10 marks, where each sub question is of 2 marks each. When they are talking about sketching the signal, they want you to draw the original signal and the modified signal. Please keep that in mind. If you don't draw the original and the modified signal, then you are going to lose on marks. Okay. Now let's see the first one, the solution for the first. Before that, we are going to draw the original signal. X of n 2 3 4 1 1 2. Okay, at 0 it starts with minus 1 actually, so this is minus 1. At 0 it's 1, at minus 1 it's 1, at 0 it's 2, at 1 it's 1, at 2 it's 1, and at 3 also, no, at 3 it's 2. This is how the original signal looks like. Okay, now let's do the first one, which is x of n minus 2. Okay, now this concept, if you all have seen the previous videos and if you all know what operations of signals are, this concept is called as time delay. I have taken examples of time delay in the previous videos, so I am not going to waste time by explaining how to actually solve this. I am just going to write the solution for this, and I am just going to draw the signal for this, and then I am going to tell you how I got it. Okay, so again I will have to draw the x axis and the y axis. On the y axis I will have x of n minus 2. Okay, on the x axis I will have these numbers, and on the y axis I will have 1 and 2. Okay, now what happens is the signal is delayed by 2 units. Time delay means you are delaying the signal by 2 units. So what is happening is, look at the original signal over here. This is 1 unit and this is 1 unit. the signal is delayed that much. So the signal is going to, instead of starting from -1, the signal is going to start from 1. The signal is going to remain as it is. This amplitude is going to remain as it is. Okay, but it is going to be delayed by 2 units. So the modified signal is going to look something like this. Like I said, now it's not going to start with -1, it's going to start with 1, and the values are going to remain the same. It is just going to get shifted to the right by 2 units because it's x of n minus 2. If you have any, if you still have any doubts on how I actually got the solution of this, you all can refer to the video that I have uploaded for time delay. Okay, so this is how I got the solution to my x of n minus 2. The second one, this is A actually, okay, the B sub question is x of n plus 1. This is called as time advance. Okay, just simply going to draw the signal here. N, this stands for x of n minus 1, plus 1. This is 1, this is 2, this is 0. Okay, advance as in the signal arrives earlier. Okay, advance is the signal arrives earlier. Now 1 over here means it is arriving earlier by 1 unit. So let's see my original signal over here. This is my original signal. My original signal starts at -1. At time advance, what is going to happen? It is going to start at -2 because it will arrive by 1 unit early. Okay, so that is the concept behind it. So what I am going to do here is, the values will remain the same, just that the signal will arrive earlier than it has arrived in the original signal. Okay, so this is how it's going to look like. 1 over here. Okay, so this is how the modified x of n plus 1 is going to look like. Now the third type of signal that we are going to see is the third question, the third sub question, which is C, and it is x of 3 minus n. Okay, I am going to rewrite it to make it a little easier for me. It's minus n plus 3. Now again, if you have seen the previous videos, this concept is called as folding and delaying. Okay, why it is called so is explained in the video itself. Okay, I am just going to jump to the answer now. Okay, just going to draw the signal here, n. Okay, now what I am going to do is I am going to explain how I get the signal directly. Okay, just by looking at the original signal, I can make out what x of minus n plus 3 is going to be. Okay, before that I will just draw the signal. First I am going to perform x of minus n, and then on this signal I am going to perform plus 3. Okay, so then this is going to be the final one, x of n minus n plus 3. All right. Okay, now when I talk about x of minus n, I know what my original signal is. My original signal is x of n. Okay, when I say x of minus n, I am doing nothing but reversing the signal. When I reverse the signal, it means that I am taking the mirror image of the signal. Okay, now what mirror image am I talking about? My origin is going to remain the same. Okay, so my origin, what was the value for my origin in the original signal x of n? It was 2. Okay, so this is going to remain the same. in the origin, whatever in the original signal, whatever was on the left hand side is going to come on the right hand side, and whatever was on the right hand side is going to come on the left hand side. So that is called as folding, or that is called as reversing of the signal. Okay, origin will always remain the same, the rest everything will get reversed. So at -1 I had the value of 1, so at 1 it's going to be 1. If you still have confusion, kindly see the video on signal reverse, which I have previously uploaded. So this is how a folded signal looks. Now for this signal I am going to perform delay. Okay. Now what is going to happen is, this signal is going to get delayed by 3 units. This is the first unit, this is the second unit, this is the third unit. In this case my signal is starting at -3. When it just delayed by 3 units, it is going to start at 0. Okay, so this is how the signal is going to look like. My final signal, the output signal, is going to look like this. Okay, so just writing the values over here. Okay, so this is how my modified signal is going to look like. This is my third sub question solution. Alright, now let's move on to the fourth sub question solution, which is nothing but D, that is x of n into u of n minus 1. This is u. Okay, u is nothing but my unit step signal. Okay, this is explained in the video, in my previous video. The title of the video is standard discrete time signals. Okay, please, I have explained 3 standard signals: unit step signal, unit impulse signal, and ramp signal in that video, in which you will understand the concept of unit step signal as well. So I request you to please see the video if you have not already seen it. Okay, now let's we already know what the value of x of n is. So it's 1 2 1 1 2. All right, we know what the value, the series of u of n is. So it's nothing but 0 1 1 1 1. Okay, my origin is going to be here. I'll make the origin over here. Now u of n minus 1 is nothing but delaying by 1 unit, right? Advancing the signal. I'm sorry, not advancing, delaying the signal by 1 unit. Okay, so this will look something like this. What I am doing is simply shifting the signal to the right by 1. That means the origin is going to be shifted to the left. Okay, previously the origin was over here at 1, but when it is shifted, when the signal is shifted to the right, you have to imagine it, when the signal gets shifted to the right, the origin gets shifted to the left. So that's why my origin is over here. Okay, so let's say this is 1, let's say this is 2, and let's say this is 3. Okay, now as per my question, my solution would be to multiply 1 and 3. Okay, now when you are multiplying, you have to make sure that you are considering the position of the signals. Okay, so you are multiplying whatever the value of origin, or the value at -1, or the value at 1 at both the signals. Okay, so you have to check before you multiply what is the positioning of the signal. Okay, so I'll start multiplying. I'll just write this over here: x of n into u of n minus 1 is equal to, at -1 my x of n is 1 and my u of n minus 1 is 0. So 1 minus 1 into 0 is 0. At 0 my x of n is 2 and my u of n minus 1 is 0. 0 into 2 is 0. At 1 my x of n is 1 and my x of u of n minus and my u of n minus 1 is 1. 1 into 1 is nothing but 1. Here x of n is 1, here u of n minus 1 is 1, so this is 1. Here this is 2 and u of n minus 1 is 1, so this is 2. Okay. So this is the solution to this numerical. Okay. Now one of the most important thing that you have to do is draw the signal. Okay. The final signal has to be drawn, the final signal has to be sketched. So I am just going to do it here. X of n into u of n minus 1. This is how it will look like. Okay. So this is my final signal. Now let's move on to the fifth subpart of the question, which is nothing but x of n minus 1 into delta of n minus 1. Okay. Delta is my unit impulse function. So I know my x of n is 1, 2, 1, 1, 2. My x of n minus 1 is something that I have already computed, which is 1, 0, 1, 2, 1, 1, 2. Okay, this is the origin. Then I have my delta n, which is nothing but 0, 1, 0, 0, 0, and I have my delta n minus 1, which is nothing but 0, 0, 1, 0, 0. Okay. What I am doing is, I am doing nothing but shifting the signals here and there, okay, because the question demands it. In the end, I need to have a value for x of n minus 1 and I need to have values for x of for delta of n minus 1, which is exactly why I am doing these steps. Alright, and the number of, now you all will get confused between why I have taken only so many number of zeros, whereas impulse function is an infinite series, because my question has just 5 numbers. That's why I am for my impulse signal also, for my impulse function also, I am just taking 5 values. I am just considering 5 values because I know that the rest of the values are 0, so they don't really matter. What matters is that I am performing the operations with the signal that is in consideration, which is nothing but my x of n. Okay. So let's say this is 1, this is 2, this is 3 and this is 4. To get the answer, what I have to do is multiply 2 and 4. Okay. So the solution is x of n minus 1 into delta of n minus 1. Final series is multiply, looking at the position of the signal and the position of the arrow, the final series will be given as this. This is how the final series will look like. Now we have to draw the modified graph, okay, of the final answer. 1, 2. This is nothing but x of n minus 1 into delta of n minus 1. This is minus 1, this is 0, 1, 2, 3, 4. Okay. At minus 1, answer was 0. At the origin it was 0. At 1 it's 2. At 2 it's 0. At 3 it's 0. At 4 it's 0, and so on. So this is my final signal. So this is how you solve the numerical on your operations of signal. Okay, it's not very difficult and it is asked for around 8 to 10 marks in exam.